In this video, we're going to rewrite rational and then later radical functions using first negative exponents, then fractional exponents, maybe even negative fractional exponents at the end, and using the power rule to differentiate, and then we're going to simplify and rewrite them back in their original form when we're done. So we've got a little chart here to help us. So number 25, we're going to start with the function y is equal to 2 over 7x to the fourth. And our first step in our chart tells us to rewrite. So what we want to do is we want that 2/7 to be a coefficient, and we want that x to come up as a negative exponent, like so. So this was our original function. When we rewrite it, we're going to rewrite it like this. Now we want to differentiate. And so that's going to be y prime is equal to a -8. 2 times a -4 is a -8 over 7. X to the -4 minus 1 will be a -5. And then our last step is going to be to simplify our answer to write it back in its kind of original form here. So y prime is going to be -8 in the numerator, and then 7x to the fifth in the denominator. So that's your fourth column in that table. I just don't want to write so small that I can fit those 4 columns on there. I want everyone to be able to read what I'm writing. So let's go ahead and look now at number 29. 29 starts with the function y is equal to 4 over, and then in parentheses, 2x raised to the -5th power. So that's going to be the same thing as y equals 4 times 2x raised to the 5th is y equals 4 times 2 to the 5th times x to the 5th. It's y equals 4 times 32, or that's 2 to the 7th. 2 to the 7th is 128 x to the 5th. So we've got our rewrite done. Now y prime is equal to 5 times 128 is going to be this is 40, and then that's 10, and 4 is 14, and 5 and 1 is 6, x to the 4th power. And I really don't need to rewrite that at all, I don't think, but let's see how they tell me that that is fine. So their steps here, rewrite, and they just wanted you to write in this step 128 times 5 x to the 4th, and then to simplify, that's the multiplication step that I did, where I got 640 x to the 4th. Let's go ahead now and look at number 31. This is where we're moving into radical functions, which have fractional exponents, but it's the same kind of chart that we were just dealing with. So number 31 says y is equal to 6 times the square root of x. So my rewrite step, we'll rewrite that as y is equal to 6x to the 1/2 power. Square root is 1/2 power. Then I'm going to differentiate. I'll just abbreviate that, DIFF. So y prime is equal to 6 times 1/2 x to the negative 1/2 power. And then to simplify, I'll just abbreviate that SIMP. Y prime is equal to 3 over, and this x to the 1/2, x to the negative 1/2 comes down and becomes a square root in the denominator. So let's see if they left it down there. Yes, they did. They did not rationalize that denominator, so that's okay in calculus for you to leave a square root in the denominator like that, even though you didn't do that in pre-calculus. Let's move on here and talk about number 35. And now we have our function. Y is equal to the 5th root of 8x. So my rewrite of that is going to be 8 to the 1/5 power, whatever that is. So I might just write that as the 5th root of 8 times x to the 1/5 power. Now when I differentiate, that's going to be 1/5 times the 5th root of 8 times x to the 1/5 minus 1 will be negative 4/5. And when I simplify, I should get, and these should all be y equals. This is y prime equals. Y prime equals. So this should be the 5th root of 8 over 5x to the 4/5 power. Now they do want me to rationalize this one when I simplify and make sure that I get rid of this fractional exponent in the bottom, so they're not being completely consistent here, but that's because I have a 5th root in the top as well. So they want me to take the 5th root of 8 times the 5th root of x over x, 5x to the 4/5, and this 5th root is the same thing as an x to the 1/5. 4/5 plus 1/5 is going to give me an x to the 1st in the bottom. And when I multiply the roots with a common index, I can put them together under that common index, that the nth root of a times the nth root of b is the nth root of a times b. So 8x underneath that 5th root sign. This is not a cube root, it's a 5th root. Make sure you see that that's a 5 there. All right. And that will be it for this video. We're going to come back next time and we're going to find some slopes just like we did in the last section, but last section we did it with the limit definition of the derivative. Now we're not going to use the limit definition of the derivative. We're going to use the power rule, and it's going to simplify the process greatly. So we'll come back next time to do that. See you for the next video.